So good morning. Today actually I'm going to start that remaining part of last class. Actually till now I have discussed about the coordinate system, system 2, divergent, del cross curl, gradient. Okay, till now I have discussed the coordinate system and divergent, gradient, curl. Okay, and meaning of that t parameter, and this is a vector calculus. And this part, basic understanding of coordinate system, as well as specifically and spherical and cylindrical coordinate system, and divergent and curl gradient in three coordinate system, spherical, cylindrical, specifically cylindrical and coordinate system is very important, and it is essential to understand the electromagnetic phenomena. Otherwise, if you don't understand this coordinate system, apart from rectangular coordinate system and gradient, divergent, curl, these all parameters associated with electromagnetic theory. So we have to understand, and this part I have already discussed in the previous class, and numerical problem also discussed, and some numerical problem I will give you in order to understand the meaning of different terms, and after the once it is complete, then again I will discuss the different type of possible numerical problem that often asked in exam. Okay, but don't think that in exam is very hard numerical question put in exam. No, it is online exam, so they will give a basic question, so that and want to ensure whether you have understood or not. Okay, so basic understanding of physics is very essential in order to qualify NET, GATE, SLET, and these all exam are related to the basic understanding, not a big derivation, big numerical analysis. No, not necessary. So I will discuss today theory, divergent and Stokes theory. Two theorem I will discuss. There is a theory we have to study. There is one is a Gauss divergence theory, one is a Stokes theory, okay, and one is a green theory. Green function is very essential. This green function you have to study in mathematical physics, as well as this green function you have to study in quantum mechanics also. As well as this green function is associated with the electromagnetic part, but the green function is not so much applicable in electromagnetic courses. So I am not going to discuss the green theorem. Green theorem I will discuss in quantum mechanics. Okay, and today I am going to focus on two parts. That is divergent theory and Stokes theory. What is the divergent theory? Divergent theory. What is the divergent theory? And why it is so essential? Because we have to encounter Maxwell equation, divergence of E, divergence of B, del cross E, del cross B. So we have to understand what is the divergent theorem. State that divergence of any function, suppose V means any function, it may be electric field, it may be magnetic field, it may be power flux, any function, any mathematical entity over a volume V equal to, you can express in the closed path surface integral that V dot ds. Okay, this is the divergent theorem. I'm not going to discuss the detailed history and all, why derive and how derive. I'm not going to discuss this, because as per course this is not necessary. Okay, this is the divergence of any function over volume V, you can transform to the surface integral. This is called divergent theorem. And why it is necessary? Sometimes what happens, this divergent function is very big function, and it is very difficult to find out this parameter or this parameter. Okay, then what happens, this term will help to calculate the total integral value. Okay, this is the theorem, divergent theorem, and I am giving one example. I am giving one example. Calculate the divergent V. Calculate example 1. If V is equal to y square x cap plus twice x y plus z square y cap plus twice y z z cap over a unit volume. unit q calculate divergence of v dv equal to how much? Calculate. So this is the question. It is over a unit q. You can calculate it this way. Solution, we have to find out the divergence of v equal to how much? Divergence of v means sum of I LL x dot this function v function. It will what happen? This is with respect to x. It will be 0. X, there is no x. This is x cap. This is y cap. Y cap equal to how much? Equal to twice x y plus this is z twice y z cap. This is, or you can express 2 into x y cap plus y z cap. This is the value divergence of v. Okay. So now we have to calculate divergence over volume. Why it is volume? This is the integral value, and now we have to calculate this is that value and find the divergence. Now one question is that divergence of v equal to bc, because it is scalar, so that's why I am putting in the wrong way so that you may confuse. This is v dot product. Okay, this is a vector, this is also vector. Dot product is a scalar quantity, so you will get, so you will never get it. I simplify if you confuse. I d by dx plus j d by dy plus k d by dz. Dot product into v part. So corresponding term will differentiate. You will have twice x plus y. This one. Okay. But in previous one I put twice x y cap twice y z cap, but this is wrong. Okay. That's why I am giving you. So do not confuse divergence of v. This is the dot product of two vector, always a scalar quantity. So now what is the total integral? Total, this is a small, this is a cube, this is cube. Okay, this cube, this is a cube over a unit cube. How many surface area? This is y axis, this is x axis, this is y axis, this is sub z axis. Okay, I have told you number of surface area depend on degree of freedom. There is a 3 degree of freedom, x, y, z, 3 direction, so there will be 3 surface area, and 3 surface area opposite to the that. One surface area is this one is opposite. This is 1, 2, 3, 4, 5. This is 6 surface area. One is along this direction. This is along this direction. This is along other direction. This is along this direction. This is along this direction. This is along this direction. Okay. Total 6 number of surface area, and this is along this direction. Okay. Now, if I calculate the divergence, if you integral divergence of v dv, we are getting 2x plus y dx dy dz. Okay. Here you see dz is not there, so it is simple integral. It is 0 to 1 dz, 0 to 1 x plus y dy dx. Okay. This is unit q, that is what they have given. It is equal to, first you take the integral with respect to y, and then put the limiting value, and then you will find 2. Okay, I am not going to calculate. This is a simple integration. First you take this is first one will be for x y, next term y square by 2. Okay, then put the limit. After that again do the integration with respect to x. Okay, this way you have to do. Another way you have to do, you can say, you can verify. I am not going to read detail, because divergence of integral divergence of v dv equal to v dot ds. Okay, and you can calculate this way also. ds means how many surface area. You have to find out the surface area, this part along this thing. How many surface? 6 surface. Actually there is a 3 surface. 3 is opposite to the red. Suppose you want to calculate the surface area. V is already given. V is a long equation. So surface area, first term I want to calculate along S dx. S dx means surface along this direction, x direction. This is x direction. So whenever I consider dx, surface area along x direction, then what will be the component? It's very easy, no need to see the diagram. Okay, x is considered, remaining dy dz must be there, so there must not be x, so it will be x cap. Similarly, this is the surface area of this part, 6 part, and surface area of 4 part. 4 part is this side, so 4 part is, this is 4, 6 surface area. Okay, and 4 is opposite to the red, then dsx prime equal to minus of dy dz x opposite, and then integral, first integral you have to find out using this v dot dsx. Okay, you calculate the value, suppose m1. Similarly I2 is opposite to the v dot dsx prime, opposite that 6 place, you will get m2. This is very simple calculation. And similarly you calculate the surface area for all the vector, and then sum of it will equal to the value we found left hand side equal. We have on left hand side I have calculated, is because right hand side is calculation is very time consuming, that's why we can calculate in the left hand side, so it will be easy. So another example in this equation, this question comes in a GATE exam. This question comes in a GATE exam. Another example, if r v equal to xi plus yz plus zk is the position vector, then find the value of divergence of v dv. Can you calculate? So divergence of v means this equal to divergence of v. V is equal to this one, sum of xi. So divergence of v is a scalar quantity, sum of I d by dx dot xi. So it will be t. If you do the calculation, it will be t. So this will give t dv equal to 3v. Okay, this way you have to calculate. This is simple question. Another question is that if this also comes in the exam, exercise 2, if f equal to divergence r squared, find the integral, this also comes in the exam, find the surface integral f dot n ds, calculate the integral. Okay, in exam it is given as if f equal to del r squared, find the integral f dot n ds. How to calculate? Solution, we know integral f dot n ds, n is a unit vector, don't confuse. Okay, n is a unit vector, equal to divergence of f dv. Is it okay? So you calculate the divergence. Divergence now, since f equal to del r square. Del r square means what? Del r square means del x square plus y square plus z square. Okay, this del equal to how much? Sum of I del by del x equal to this one. Okay, this is equal to 2 into x I cap plus y z cap plus z k cap. Okay, this is equal to 2r. Okay, now f equal to, we are getting equal to 2r cap. Then divergence of f equal to how much? So that equal to 2 into divergence of r. So divergence of r is already calculated in the previous example. It will be 6. Okay, so it will be 6. it will be 6 equal to hence equal to 6 dV equal to 6V. This is the answer. This is a comes in the gate exam. Now back to the delta function. Now we have already studied delta function. Why delta function is so important? You have already studied delta function. Now I am going to study the delta function, because delta function is very important for delta function. Delta function is very important in application to the Gauss law. Whatever we have Gauss law application we have studied in HS, B.Sc, that is different. But we have to use the delta function in Gauss law. Why it is so essential? First of all, we have to know. So consider any function. Consider any function. Suppose r square. This is what? This is force equation. Force equation, you remember, F equal to what? Q1 Q2 divided by r square. This is similar force. Okay. Suppose V is a function of 1 by r in a sphere. In sphere, spherical system, sphere. So it's a. So if I take the divergence of V equal to, I have to take divergence of 1 by r cube r square. Now it is not like that. I will put d by dv sum of d by dr dot r cap r square. I cannot put like this. Okay, because I have told in a spherical coordinate system we have to use divergence theory. General theory of divergence is different. So because I have already mentioned this function is for spherical system. Okay, in that case I have to use the general formula. What is the general formula? You have remember divergence of V general formula is equal to H1, H2, H3. Okay, first term H2, H3, V1, dx1 plus second term H1, H3, V2, dx2, third term dh1 h2 v3 dx3. What is a vt? So vt means this one. V is represented in spherical coordinate. V r cap. Okay, v theta cap plus v phi cap. This is, so v theta means this component. V phi means third component. Okay. Now in this spherical coordinate system, V is given only r cap by r square. Okay, this component exists. This component is not there, so we no need to write this part. Okay, first part you consider. Why I am considering first part? Because V is given as a r cap by r, only r component is there. So this part, this is associated with theta, this is associated with phi. So this part I am not going to write. So in spherical coordinate system, H1 1, H2 equal to r, H3 equal to r sin theta. That's I have already told in the previous class. So if we put this value, then divergence of V equal to 1 by r square sin theta d by r square. V1 means VR r component, first component. Okay, dr. This will be there. Okay. Oh, sorry, one sin theta term is missing. Sin theta. This is the. So what I am getting here from this equation, I am getting here 1 by r square sin theta dr square sin theta dr. Okay, this is a scalar quantity. So sin theta, because this is with respect to r, sin theta will come out, this will cancel out. So I am getting here r square d by r square dr. This component. Is it okay? Now if I put this value VR r square dr r square, VR is V equal to r cap by r square. But don't put r cap. R cap is the unit vector of V. V is along r direction. So because divergence is a scalar quantity, only you have to put the magnitude. Okay, this is the magnitude. So r cancel. It become how much? 0. Oh, clear? Now what happened? According to Why delta function is important, that's what I am going to tell you. Okay, I am taking one example in spherical coordinate system, which is equal to VR equal to 1 by r square, and then I want to establish a relations. Okay, according to divergence theorem, divergence of V dV equal to surface integral of V dot ds. Is it okay? And this left hand side is 0. Left hand side is divergence of V is 0, so left hand side is 0. What about right hand side? Right hand side, see, V equal to 1 by r square, r cap, okay, dot r square sine theta d phi r cap. So if this one cancel, sine theta is r cap is equal to 1. So sine theta, you will get sine theta d phi. If you take the integration 0 to twice pi, 0 to pi, it will give a 4 pi. This is a contradictory statement because left hand side is 0, right hand side is not 0. And that is why, in order to avoid this confusion, in order to avoid this mathematical contradictory statement, so they have adopted the Dirac delta function. So in order to avoid this confusion, they said that divergence of V equal to integral dV equal to 0 4 pi delta E pi. That means it is 0 everywhere except at origin 0. Except at origin. Origin means it is 0 everywhere, but at the center of the circle, at the center of the sphere, this value will not 0, it becomes 4 pi. Okay, this is represented by delta function. Okay, that is why delta function has to be adopted in terms of this calculation. And this type of calculation, we often Gauss law, 1 by r square is there, divergence theorem is also there. So we have to adopt it Gauss law this way. Oh, sorry, the delta function. Delta function, that is very important. Now, what is a delta function? First of all, the delta function is defined. This delta function I have defined in three-dimensional system. Now, first of all, I have to know that what is a delta function. Delta function is defined as infinity at x equal to 0 and 0 x not equal to 0. That means this delta function, this is 0, is a infinity, infinite small length. This is, suppose if this is, suppose breadth is epsilon, then height will be 1 by epsilon. Area will be 1 by epsilon into a area is equal to 1. This is a delta function del x. Okay. This means that delta function at x equal to 0 at infinite height is small spike. Okay, but all of the point except 0 it is 0. But area of delta function is always equal to 1. It is represented by area. Okay, minus infinity to infinity equal to area is always 1 and area of this spike. Second, this is a basic. If I represent, suppose if I express the delta function, suppose this is origin, this is suppose origin, this is suppose A point. If the delta function is situated here, delta function situated here, that is represented by delta x minus A. Okay, x minus A equal to 0. That means this term is represented x minus A equal to 0, x equal to A. That means delta function is located at A. Why it is so necessary? In signal processing in electronics, apart from electrodynamics, it is very essential. Suppose why it is so necessary? I am giving an example only to understand. Suppose this is EMD signal. This is EMD signal. Okay, this is suppose this is x-axis. This is x-axis. Suppose this is 0. This is 0. This is A. This is A2. This is A3. Okay. This is a signal. Suppose fx. This is a signal, biomedical signal. Now spike is there. These are a small spike or noise. We don't need this small spike. Then what happens? If I multiply f of t, suppose delta, this is, I am considering this part, delta x minus a2. What I am getting? I will get f of a2. What does it mean? That this means that if this function means this is signal, biomedical signal, health body signal. So it is, this spike is located at A2. If I multiply that signal with the delta function at that location, then I will get the function at that location. That means I will get a function. Suppose this is that line, this is peak, and then this is suppose A2. All other remaining part will become 0. Why? Because I have multiplied delta function. So that in such application, signal processing delta function is very essential. Okay. That is the first important thing about the delta function. Second important thing is that important property. Property number 2. Delta function is even function. Delta minus of x, even function, or delta x minus a equal to delta a minus x. Okay, even function. Delta function is even function. Even function means even parity. Why it is called even function? You see, it is a spike. This is suppose 0. Delta function, this is a delta x. Okay, if it is delta x, then left hand side and equally symmetric with the right hand side. That means this is an even function. And even parity. Parity is 1. Okay, plus 1, not minus 1. And it is known as an even function. Okay. Another property, this is one property. Another property, suppose if it is property number 2, if delta a minus x, then it will be equal to 1 by modulus of a delta x. Okay. This is another property. Property number 2. This property you have to remember, because whenever we apply the Gauss law application, the Gauss law application we are going to do using delta function. So third property, suppose minus a infinity to infinity, suppose a by b, f of x delta x minus c dx equal to f of c. This is c, okay? If I take an example, this is a function, unknown function, arbitrary function. This is the delta x minus c. You take this, the x minus c equal to 0. Whatever you value, you will get the value. Suppose I am getting here x minus c equal to 0. So x equal to c. So that function is you have to apply. Suppose I am taking an example. Suppose integral minus c to d. Suppose d. This is a sin x. Sin x, this is a function I am putting, this function equal to sin x. Delta x minus c dx. Then I will get what happened? According to this function, I will get the function, only particular value. This is x equal to say sin c. Okay. That this value you have to put in place of x. Okay. But one condition is there. Provided this is valid, this condition is valid, this c point must be greater than a, less than equal b. That means this value c must be within this range. Okay. Probably you don't understand. I am giving one example. Then you will understand. According to this theorem, I am writing again. C to d, a to d, suppose f of x delta x minus c dx equal to f of c, and c must be greater than c, less than b. This condition must be satisfied. Otherwise, this is equal to 0. Suppose otherwise it is equal to, I am giving you one example. X cube delta t delta x minus 2. So dx. What you understand? The delta peak is located at which point? You see delta point is, this is 0, this is x, this is suppose 1, this is 2, this is 3. Okay. This delta peak is located at which point? 2 point. 2 is what? Is whether 2 is fall this range. 2 is fall within this range according to this condition. the limiting value, this limiting value x equal to 2 must be fall within 0 and t. Then you can put this value equal to f of x. F of 2 means f is what? X cube. It will be 2 cube answer. Clear? But I am giving an example. I am changing the limit 1. Then what happened? You see, the limiting value, it is not satisfied. Its limiting condition, we are going to calculate the integral over this range, 0 to 1 range. Okay, clear? 0 to 1 range we are going to calculate. But this delta function is located at which point? X equal to 2 point. This limiting value does not cover the delta function, it will become a 0. Okay? This is the condition. Because this delta function question often comes in the exam, any exam related to physics, or that is JEST exam, whether it is GATE exam, whether it is NET exam. Always ensure this limiting upper limit and lower limit, whether include the delta function within that range or not. If it is covered, then it is well, this rule, according to this rule. If it is not covered, it is 0. Okay? This is the one. And third property, and another property is that I go again 4 properties: delta C to D delta A minus X, delta X minus B dx. Because A minus X minus B does not affect, because I have already told delta function is a even function. You can express X minus B or B minus X, same thing. Okay, so it will equal to delta A minus B, provided this is upper lower limit AB fall in the upper limit and lower limit. This is a D. So AB, for this condition must be satisfied. This is important. Another 5 properties: delta X minus A, X minus B equal to 1 by A modulus of A minus B, delta X minus A plus delta. This is property is very important in quantum mechanics, in EFT also. This is important property. Okay. Delta X minus A, X minus B equal to 1 by A minus B, delta X minus A, X plus B. Okay. So these are the property of delta function. One question comes in the NET exam. Find the integral. Exercise 1. Find the integral. Integral. I equal to minus infinity to infinity x square plus 2 delta x square minus 5x plus 6 dx. Find the integral. This question comes in the NET exam. So how can you calculate? Using this formula. What I will get? First of all, if I take the integral, this will remain same, x square plus 2 minus infinity, it will within the limit, no problem, delta x minus 2 delta, if we take factorization method, x minus t. So what is the property? Dx. What is the property? Property is that according to this is the property, delta x minus a, x minus b equal to 1 by a minus b modulus delta x minus a plus delta x minus b. Okay. So according to the property, x square plus 2 is 2 by 3, 1 is not necessary. So delta 2 minus 3 modulus delta x minus 2 plus delta x minus 3 dx. Now it is product. It is 1. It is first term is x plus 2 delta x minus 2. Second term x square plus 2 delta x minus 3 dx. To put this value x equal to 2, it will be 2 square plus 2. It will be 3 square plus 2. How many? 9, 14. I think it is 27. 17. It will be 17. So this way you have to calculate delta function. This is a delta function property. Okay, very important. Okay. I hope you understand. Delta function in 3 dimensions. Delta function in 3D. 3D, how we represent? 3D, how we represent the 3D delta function? Delta function I have represent del x, but in 3-dimensional case we always represent as delta x, delta y, delta z. It is cube means it is 3 dimensions. Okay, area of delta function delta cube r d cube r equal to 1. This is the area. Integral of area equal to, do not confuse, delta function is, area of delta function is 1, but the delta dx is not equal to 1 at x equal to 0. Okay, suppose if I write delta function, you can express delta function like this: f r delta cube r minus r dash. This is also del r equal to f of r, sorry, same property is similar to the one dimensional case. Okay. Now in the earlier class I have tell you the divergence of V is equal to 0. Left hand side and right hand side is not 0. In order to avoid this confusion, we always equal to divergence of r cap r square is equal to 4 pi delta cube r. This formula is very, very essential, because in the last exam I have seen the question, they asked that express the Gauss divergence theorem in terms of delta function. Question is like that. Okay. So this again another problem. This is related to the delta function. Delta function is very easy. Example 2. This question comes in net exam. Net gate exam. This is very 5 marks question. You see, find the integral. Find the integral. Question is find the integral. Find the integral. Integral I equal to volume integral V r square plus 1 divergence of r cap r square d cube r. D cube r means dv. Okay, find the integral. It is look very tough example, because I have already told integral V, this is r square plus 1. This is a formula according to the delta function. It will be equal to 4 pi del cube r r dr. Dr means dv. Okay, so you put, because r here only r, so r equal to 0. So put this value, you will get a 0 square plus 1 into 4 pi equal to, answer is 4 pi. This is a 5 mark question in the net exam. Okay, question look very tough, but answer is very easy if you understand. Similar question comes in a Z. This is also comes in a GATE exam. This comes in a net exam. So another question I want to tell you, I am strictly following the David Griffiths book. I strongly advise you to follow the David Griffiths book, because no question will be asked except from this book. All question, any question, whether in GATE, whether in NET, all question must be from David Griffiths. And they have clearly mentioned no question will be. This is not from my statement. This is the statement provided by UGC during that booklet. I got in 2010, 19, 11 during my M.Sc. Okay. This question also come, find the integral J equal to e to the power minus r divergence of r cap r square d. This question also comes in exam. It look very tough. Divergence and something, many other calculation. This is 3-dimensional. You may think that it is 3-dimensional. Divergence is very long expression. No need to do, because integral e to the power minus r. This is what 4 pi delta cube r dr. Okay, this put this value e to the power 0 into 4 pi equal to 4 pi is the answer. Okay, this is only 1 or 2 steps. This is 5 mark question in net exam. Okay, I am not going to do more calculation, but why it is so necessary, I will tell you. This also question comes in some exam. Question is that express the Gauss divergence theorem. Which of the following statement is correct? correct form of divergence. You see, divergence of E equal to how much? Divergence of E is equal to what? You know this formula, E equal to 1 by 4 pi epsilon naught r k by r square. You know this formula. So what I can write divergence of E, so divergence of E equal to divergence of 1 by 4 pi epsilon naught r k by r square equal to, I can write 1 by 4 pi epsilon naught, okay, divergence of r by r square. Is it okay? So this means that 4 pi 1 by 4 pi epsilon naught 4 pi delta q r. This is the expression of Gauss divergence law in delta function. Okay, this is one or two steps. Only you have to understand. So another question, why Gauss delta function is so important in application of Gauss law? Because you don't think that I am going to give the application of Gauss law in terms of some basic calculation or whatever we have done in B.Sc and high secondary. It's a different. This application of Gauss law will be different and question will be different. Okay, don't do calculation find the electric field of a sphere, outside the sphere, inside the sphere. That calculation I'm not going to ask. Maybe ask simple one or two questions. But this delta function, application of delta function in application of Gauss law is very, very essential. So, question is that you read the question very carefully. A point search density of search Q located at a point R dash. Okay, find the search density in terms of delta function. Okay, that means what? A search density, search Q located at a point R dash. Okay, express this function, this search density in terms of a delta function. How can you represent? It is because this Q, rho search density equal to what? This Q is located at which point? Because this search Q is located only single point of the line. So you have to specify that line. That equal to what? R minus R dash. This is the correct expression. Okay. What is the total search density? Now if you calculate the total search, Q equal to rho dV. Is it okay? Rho equal to what? Integral this Q into delta function R minus R dash dV. Or equal to Q will come out this delta R minus R dash dV. It is the area of delta function. It is Q. Okay, you understand? This is the application of delta function. Another example. This question comes in the GATE exam. Another example you see. Find the search density in terms of delta function. Okay, find the search density in terms of delta function. Two search is located at point. This is 0 point. This is A point. This is minus search Q and this is search Q. Okay. Two positive and negative search, that is a dipole, is located at point 0 and A. Express the search in terms of delta function. This question comes in the exam. So how can we search density? How can we express search density? This first search, see, simple. Q1 is delta R minus A. Okay, plus Q2 delta R minus B. So Q1 means this one Q, this one is Q. Minus search located at which point? Center 0. And next one is plus search Q located delta R minus A. This is what? Q delta R minus A and minus Q delta R is the correct answer. This is the correct answer. This is why understanding of delta function is very, very essential. Okay. Another question comes in the GATE exam. These are the comes already GATE. So third question is that a search density of, you listen the question carefully. A search density of infinitesimal cell is defined. A search density of infinitesimal cell is defined as, this question comes in the exam, net exam, A delta R minus R, where R is the radius of the cell. Again I am telling, in charge density of infinitesimal cell is defined as this one, and where R is the radius, find the value of A and charge density. Okay, this is charge density. What is the value? The total charge equal to rho dV, right? Rho means this one, integral A delta R minus R, clear? dV means what? R square sin theta d theta d phi dr, correct? Okay, this is a function of R, this is also function of R, only R you can take, A will come out, R square delta R minus R dr. Okay, next 0 to pi sin theta d theta, 0 to twice pi d phi. This will give 2, this will give twice pi, it will be 4 pi A integral R square delta R minus R dr. Okay, this will give what? Equal to, you have to put the R minus R, R small r minus R equal to 0, to take small r equal to capital R, so it will be 4 pi A R square. Okay, and value of A, thus A equal to Q by 4 pi R square. This is the value of A. Okay, this way you have to calculate. Okay, and then the total charge, can you calculate the total charge? Total charge, this is the A value, and density you can easily calculate. I am not going to calculate this. So that is why the understanding of delta function is very, very essential. And next I will not discuss more because you will get a confusion. Okay. This also another last question I will discuss. Last question. You read the question. A sphere radius 0.2 meter. A sphere radius 0.2 meter. This question comes in exam also. This a sphere of radius r equal to 0.2 m. Okay, having charge density rho equal to 2 by under root of x square plus y square c by meter cube. Find the total charge. Now it is considered a sphere, so we have to transform. Sphere means there will not be x y z axis. It will have a r theta phi. Okay, we have to convert. That means solution, we have to put x equal to r cos theta cos phi, cos theta sin phi, and y equal to r sin theta sin phi. You don't ask me from where I get. This expression is from coordinate transformation. So you put this value, you will get rho equal to 2 by under root of x square plus y square equal to 2 by r sin theta. Okay, and total charge q equal to rho dV. Rho means this one, 2 sin theta and r square sin theta d phi dr. Okay, this sin theta cancel, then r will be cancelled, 2 will come out, 2 this r dr, and 0 to pi sin theta d theta and 0 to twice pi d phi. Okay, and this simple calculation you can do easily. Okay, that's what I am going to give you. This you have to do the calculation. And another question I am giving you to you, but I am not going to solve. This question comes in the exam, that potential of exercise. This is for exercise. The potential of neutral hydrogen atom is given as V equal to VR equal to Q by 4 pi epsilon naught e to the power minus alpha r by r 1 plus alpha r by 2, this one. This question comes in the NET exam, okay? And I'm not going to give you the solution, but I will give you hints. So calculate the size using delta square V equal to delta square rho by epsilon. Okay. Charge density. If the potential of a neutral hydrogen atom is given by Q by this one, so calculate the charge density using that formula, and your answer would be rho r equal to minus alpha q by r square 8 pi r square e to the power minus alpha r. Your answer should be like this, and delta r2. Your answer must be like this one, and I am not going to do that. Okay, thank you. In the next class, we will do the application of Gauss law using this delta function, and this delta function will simplify the most of the Gauss law application, and some basic application which are related to previous study. Previous study means many things we have already studied in SS and as well as B.Sc. That part 1 or 2 example I will give you, but mostly I am focusing on application of Gauss law using delta function. Okay, thank you.